Geometry Common Core, Regents Review, video number 3. The figure below shows a rhombus with non-congruent diagonals. Which transformation will not carry this rhombus onto itself? Well, to understand if a shape will reflect over its diagonal onto itself or rotate onto itself, you really need to understand the properties of these shapes. So if we're discussing the rhombus, a lot of these parallelogram property questions stem from the difference between a rhombus and a rectangle. So if we just take a quick second and review the rhombus versus rectangle relationship. Because what's interesting about the rhombus and the rectangle is that in a lot of ways they're kind of like opposites of each other, meaning they both have something special congruent and they both have something special perpendicular. And by special, I mean things that the parallelogram doesn't have, because these are parallelograms, so they already have the basic parallelogram properties such as opposite sides congruent, opposite angles congruent, the diagonals bisect each other. Like, those are the basic parallelogram stuff. But what does the rhombus have that adds to that? Well, what does it have congruent? Well, we know that opposite sides of a rhombus are congruent, but in the rhombus we also have all four sides, or another way of thinking of it is adjacent sides. So adjacent sides are congruent for the rhombus, the sides next to each other, which really means all four sides because you already have the opposite. Now in the rectangle, if I just draw a sketch of a rectangle here for visual, the adjacent sides are clearly not congruent, but they are perpendicular. So you see that what's congruent in the rhombus is perpendicular in the rectangle. Now how about what's perpendicular in the rhombus? Well, it's certainly not the sides, that's not a right angle, but the diagonals are perpendicular. And in the rectangle, the diagonals are definitely not perpendicular, but the adjacent sides are. The diagonals are congruent. So again, you see that relationship that's kind of like an opposite. What's congruent in one is perpendicular in the other. What's congruent in the rectangle, the diagonals, is perpendicular in the other. And then there's one other special property for the rhombus that doesn't have this opposite relationship here, is that the rhombus diagonals also bisect the angles. Like this diagonal here is bisecting this angle here, and this diagonal is bisecting this angle. We don't see that in the rectangle. The diagonal does not bisect the angles. And so that's what's special here. And that's related to these two options here. So we want to know what's not going to carry it onto itself. Well, if the line of reflection, like this diagonal, is an angle bisector, then it usually works as a line of reflection, because I know this side's going to map to this side because adjacent sides are congruent. And because this angle is the same as this angle, when I fold it over this line, the angles fit, the sides fit, so the diagonals are lines of reflection. The rhombus will fold on itself over the diagonals. So these are both true, and we're looking for not. Always circle the word not. So then the next two choices are just, about the intersection of the diagonals. Rotate 90, rotate 180. Which one works, which one doesn't? And if I trace the shape out, it's really easy to see, and you could probably guess it. But if I rotate it 90, you can see that it doesn't work. It doesn't quite map onto itself. But if I spin it the full 180 upside down, it does. And so that means that this is true, but this is false, and that's the one I'm looking for. Number 2 is another quick parallelogram property, but this time it's just about the parallelograms. What's always true about parallelograms? Are the diagonals always congruent? No, that's a rectangle. Do they always bisect each other? Yes, but let me check my other choices. That's probably it. Are the diagonals always perpendicular? No, that's the rhombus. Do the diagonals always bisect, not each other, but bisect the angles? That again is the rhombus. So bisect each other. That's the only diagonal property specific to the parallelograms. When you get to the bisecting the angles, the congruent, the perpendicular, now you're getting into the rectangle rhombus realm. All right, the third question, just in the interest of saving time, because there's a lot of material that this video needs to cover, I rewrote this question out, and I'm just going to kind of reveal some of the work and the answers to you. So feel free to pause the video at any time to copy this stuff down if you didn't try it before watching the video. So what we're trying to do here is prove this is an isosceles right triangle, and coordinate proofs are all about mainly about three specific formulas: your distance formula, which I have here, and your slope formula, and then your midpoint formula. But to prove something's isosceles, I'm looking for two congruent sides. That's a distance concept. To prove something's a right triangle, I want to show it as perpendicular sides. That's a slope concept. So I'm using my distance and slope formulas. Midpoint formula is not needed in this question, but it is often needed for parallelogram coordinate proofs. So distance, I'm subtracting the x's, squaring it, subtracting the y, squaring it all in a giant square root. And so I plotted the points, and I could tell it just looks like AC and BC are congruent. So I did my distance formula, and here's the work for the distance of AC. Subtracting the x's, subtracting the y's, squaring them. It doesn't matter if these numbers come out to be positive or negative, because after we square them, they're positive. It came out to be rad 34. And then I did the distance for BC, and again, it came out to be rad 34. So it is isosceles. Now, to prove it was perpendicular, to prove it was a right triangle, I did my slope, y2 minus y1 over x2 minus x1. And that's really your left point minus your right point when we do second minus first. And so the slope of AC was here, came out to be negative 5 over 3. And you see that, it looks like it's down 5 over 3. But the slope of BC is up 3 over 5. And those are perpendicular. They are negative reciprocals. One's positive, one's negative, and they are, each other flipped upside down. After you do all the math for coordinate proofs, you got to write a statement. So here's my concluding statement. Triangle ABC has two congruent and perpendicular sides. This is the symbol. Therefore, triangle ABC is isosceles right. So if you know your formulas and know what they do, these coordinate proofs are very doable. The next topic I wanted to cover, I'm going to do a couple of examples of this, is trig. Now, from a point on a ground 1/2 a mile from the base of a historic monument. So let's try to sketch this picture out. So we got a historic monument. I'll draw this beautiful monument right there. Super artistic. Okay, so there's a point on a ground that is 1/2 a mile from the monument. The angle of elevation to the top of the monument is 11.87 degrees. And this was 1/2 a mile. To the nearest foot, what is the height of the monument? Now, anytime you have a sketch or an image that's a triangle, and this is a right triangle, because the monument's standing right up perpendicular to the ground, and they give you an angle and talk about size. This is trigonometry. This is SOHCAHTOA. But there's one added little piece to this that you need to be careful with, and this is something that shows up once or twice on your exams. Always watch out for it anytime they're talking about units. They gave us this in 1/2 a mile, but then they want the height in feet. That's not the same unit. On your reference sheet, they do give you that 1 mile is 5,280 feet. So 1/2 a mile is 22,640 feet. So instead of thinking of this as 1/2 a mile down here, I'm going to convert it to feet. I'm going to put it as 2640 feet because I want this in feet. And so you got to work in the same unit throughout the triangle. And so just watch out and circle the units as you go. Make sure there's no conversion. Now, there's 3 trig ratios, and you got to know them well. Sine involves opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So which one are we working with here? Well, from this angle's perspective, opposite is across, so I'm looking for the opposite side. So that's this or this. And the longest side is opposite the 90-degree angle. That's the hypotenuse. That's not involved in this question. So we're not using this or this. And this would be considered the adjacent side. It's next to the angle, but it's not the hypotenuse. So I'm working with opposite and adjacent. Clearly, this is a tangent question. And the way you set up your trig equations is first you write the function, then you write the angle, and then you set it equal to the ratio, opposite over adjacent for tangent. So that's opposite is x over the adjacent 2640. And then you put this over 1, you cross multiply. And here cross multiplying, we just end up multiplying the 2640 times the tangent 11.87. And as long as your calculator's in degree mode, you're going to get the right answer. This one rounds to 555. Now again, because this is a long video, I did this next question all worked out for you already. And just really quickly show you, just wants to know basically which of these ratios is true. They want to know which one would help you find the angle. And now finding an angle, you're actually going to do inverse trig, and that's going to be in another video. But if we just kind of look at this question, The sides that they gave us from angle A are 8 and 17. That's adjacent and hypotenuse. That would be this. Cosine is adjacent and hypotenuse, but that choice wasn't there. And the reason was because you first had to find this missing side. And anytime you have two sides and you're finding the third, you could do the Pythagorean theorem. And it worked out to be 15. So once you had that 15, then you could see choice D, opposite over adjacent with tangent, was true. Last question I want to cover in a couple of minutes is, this is probably, I think this is a part 3 question. So as modeled by the diagram below, this is a ramp going up to steps on flat ground, and each step is 6 inches tall and 8 inches deep. And there's 2 questions here. First, determine the length of the ramp to the nearest tenth of a foot. Now again, they're giving us feet, but these are all in inches. Well, 6 inches is half a foot. And you just need to know there's 12 inches in a foot. That's actually not on your reference sheet, but I would convert this into one big right triangle to make this thing a little bit easier to look at. And this height here, since it's 6 inches to this point, 6 inches to this point, 6 inches, is a total of 18 inches. But if I divide that by 12 inches, I get it to be 1.5 feet. And so this is 1.5 feet. And they tell us the angle of elevation is 4.76. And we want to know the length of the ramp. I'm going to call it R. So first, from opposite, 4.76 is 1.15, and the hypotenuse is R. Opposite, hypotenuse, if we look at our ratios, opposite and hypotenuse, that is the sine ratio. So I'm going to create a sine equation. Sine of the angle, 4.76, equals opposite 1.5. So again, I want to work in feet because I want my answer in feet, over the hypotenuse we don't know. Now the difference here to the trig question we did last time, notice when we have this one, x was on top of the fraction. And so when we cross multiplied, it was just multiply these two things and you're done. But here, if x is on the bottom when you cross multiply, you get an extra step. And so when I multiply, it's x times sine 4.76 equals 1.5 times 1. It's just 1.5. But x isn't alone. And so since this is x times sine 4.76, I got to divide by the sine 4.76. And so I end up dividing in this question. All right, so, sorry, I just paused it for a second because I needed to grab my calculator. Now here, again, when x is on the bottom, remember it becomes, a little extra step of division. So the way I always teach it is if x is on top of your trig ratio like this, it's going to end up being the side times the function and the angle. But if x is in the bottom of your ratio, when you cross multiply, it ends up being the side divided by the function angle. And if you type this in and round it properly to the nearest tenth, we get that r equals 18.1. Now, again, in the interest of saving time, because we're already at the 13.5 mark, I just have the rest of the problem here. Because then they want to know what is d down here. But d only goes to this point, and our triangle that we made has 8 inches, which is 16 inches extra. So first I found the length of the whole bottom. I drew another triangle here and found the whole length x, and that was an opposite adjacent, so it was a tangent function. It came out to be 18, about 18. And then I subtracted off the 16 inches, which is 4/3 of a foot. So properly done, that comes out to be 16.7. Sorry the video is running so late. It's just a lot of material to cover. And again, hopefully you pause it, rewind, rewatch, whatever you need to do, and ask your teachers if you have any questions. Good luck on the test.